विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ।
Hello listeners, you're listening to Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Priyanshu and post-production by Professor Kaushik P. Kanchan of Garden City University, Bengaluru.
Garden City University, conquer we shall all adversity. GCU, emphasis on life. GCU, emphasis on life.
Today we have the privilege of speaking with Dr. S. Krishna Prasad, a pioneering physicist with a distinguished career in the study of liquid crystals. Dr. S. Krishna Prasad earned his PhD in 1987 from the prestigious Raman Research Institute, Bangalore, specializing in the physics of liquid crystals. His expertise has taken him across the globe, from a visiting scientist position at the Technical Universität in Berlin, Germany, to groundbreaking work as postdoctoral fellow at the Naval Research Laboratory in Washington, D.C., USA. Dr. S. Krishna Prasad has also contributed significantly to international research, holding visiting scientist roles at the Hungarian Academy of Sciences and the National Institute of Materials and Chemical Research. Dr. S. Krishna Prasad has also contributed significantly to international research, holding visiting scientist roles at the Hungarian Academy of Sciences and the National Institute of Materials and Chemical Research in Tsukuba, Japan. Additionally, he has worked as a research manager at the National Institute of Advanced Industrial Science and Technology in Japan and was a JSPS fellow, further expanding his global research impact.
Just I will say a few words in the beginning. You see, I work on what are called liquid crystals. This work we started way back in 1964. I completed my master's degree in that year and took up research work with Professor S. Chandrasekhar, Fellow of Royal Society, London. We were in Mysore University at that time, and we took about 6 or 7 years to complete the doctoral degree. And in 1970, we obtained the degree and then moved over to Raman Research Institute in 1971. Thereafter, I went to the DRDO as a scientist B at that point of time. And in 2004, I retired as Director Grade 1, Scientist G in DRDO. And after that retirement, I moved over to Bangalore and joined this particular center. At that point of time, this center was known as Center for Liquid Crystal Research. Later on, to expand the scope of work here, we changed the name to Center for Soft Matter Research. And that was further changed to Center for Nano and Soft Matter Sciences, which is the current name for this particular center. I have been always working with liquid crystals, electric and magnetic field effects in liquid crystals, defect structures, phase transitions, and so forth. These are the areas of my particular interest. I am engaged in research for the last, since 1964. And I have been always with research. For a period of, as long as I was a DRDO scientist, I was in the College of Military Engineering in Pune. I was posted there. And there also I was in touch with liquid crystals and I was trying to do research work alongside teaching assignments. And after joining this center, I have been exclusively doing only research and occasionally giving some lectures on soft matter sciences to PhD students. This area in which I am working opened up in the year 1888. There was a botanist, not a physicist, not a chemist, but a professor of botany, who was trying to synthesize a chemical known as cholesterol. And then he found out that this cholesterol was not actually melting into liquid at some sharp point. And then he was amazed, what is this? It was showing beautiful colors and so forth, flowing, but showing colors like a crystal. And that later on came to be called liquid crystal, in fact. And at that time, nobody knew any application of liquid crystals. And there was another German physicist known as Forlander, and he synthesized as many as 1,000 liquid crystalline materials, and he was asked, what are the technological possibilities for liquid crystals? The same question as what you are asking me now. And he said, I am afraid there is no technological application for this substance. And it took many decades. And in 1970-71, when James Ferguson in the Liquid Crystal Institute in the United States, he thought this can be used for display purposes. And today, almost every household is having liquid crystalline device. You must be having with you. All mobile phones are having it. All petrol stations are having it. The question therefore is, since 1988 to practically 100 years, nobody knew what the application was for this liquid crystal. So your question cannot be answered in that sense. Similarly, C.V. Raman was criticized during his time, and he was told, you are actually in the ivory tower and you should come down and help common people. And then, of course, there was an argument and so forth. Today, even C.V. Raman would not have imagined. And every airport is having a Raman detector of drug materials. Smugglers who take drugs, etc. And that can be, without opening the box, you can actually say that it contains the drug. And Raman effect is being made use of for that particular purpose. And therefore, there's a time lag between what you do today and what its applications would be at a later point of time. So we expect that whatever we are doing here today will be useful at some point of time later, but we can't visualize it as of now. It's an evolving kind of story. What is fundamental today is what is going to be applied tomorrow.
Yes, sir.
And most importantly, from my point of view, it is the quest for knowing what nature is. Whether it is useful to me or not is a different story. What is nature? And why are things how they are and what they are? This is a fundamental question. Intellectual, aspiration is what is driving this, this kind of research. Rather than everything that I do today should be used in my kitchen. That is a wrong argument. It need not be. These are materials which we are working on, and for example, the latest work that's going on in my field, I'm telling you, is what are known as ferroelectric pneumatic materials. Ferroelectric pneumatic materials, you don't have water here anywhere?
Yes.
These materials, I can use this?
Yeah.
They were visualized way back in 1918 by a Nobel Prize winning scientist by name Max Born. But then his theory was a failure and people did not have a ferroelectric material at all at that time. And as late as 2017, about 7 years ago, somebody by name Nishikawa in Japan actually synthesized the material, and he has shown that it is possible to have it. And if that comes through, then the display, liquid crystal display itself will change enormously actually. That means today you require about a millisecond for the response. If you switch, what it means is, if you switch off the device, it will take at least a millisecond to really go off, and that's too long a time. We want microsecond response, and these ferroelectric pneumatic materials have that kind of a response. And if this is developed into a display device, that will totally revolutionize the field of liquid crystals. So it could happen that way. And a lot of work is now going on these materials in Colorado. And right now, I have taken some of these materials from the University of Leeds, and I'm working on them. We are publishing papers on that, actually.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization, catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and also through Spotify, YouTube and Apple Music platforms.
आइए हम सुने विज्ञान की अनकही